Imagine being able to see clearly in the dead of night, just like an owl or a cat. To comprehend how this could be possible for humans, we first need to understand the science behind night vision in animals. In the animal kingdom, nocturnal creatures like owls and cats have mastered the art of seeing in the dark. Their eyes are marvels of natural engineering, designed specifically for low-light conditions. Their pupils, for instance, can dilate significantly, becoming wide portals that allow more light to enter. This is akin to opening the blinds wider on a window, letting in as much of the soft moonlight as possible. Yet the magic doesn't stop at the pupils. Deep within the eyes of these creatures, you'll find a high concentration of what are called rod cells. These tiny structures are like the night watchmen of the animal's vision, sensitive to even the lowest levels of light. They are the ones responsible for transforming the faintest glimmer into a visible image. But perhaps the most fascinating aspect of night vision is a layer within the eyes of many nocturnal animals called the tapetum lucidum. This reflective layer acts like a mirror, bouncing light that has already passed through the retina back through again. It's as if each photon of light gets a second chance to be seen, enhancing the animal's ability to see in the dark. To put it simply, imagine you're trying to read a book in a dimly lit room. The dilation of the pupils is like turning on more lights, the rod cells are like adjusting your eyes to the dim light, and the tapetum lucidum is like giving you a magnifying glass to see the words more clearly. Together, these three elements, the dilated pupils, the rod cells, and the tapetum lucidum, form the triad of traits that enable animals to navigate the dark as if it were day. So that's how night vision works in animals, but what would it look like in humans? Scene script. If humans were to develop night vision, there would be some significant changes to our physiology. Firstly, let's consider our pupils. To allow more light into our eyes, our pupils would need to be capable of dilating much wider than they currently do. Think about the way a camera lens opens wider in dim lighting conditions to capture as much light as possible. Our eyes would need to do the same. Then we'd need to talk about the composition of our retinas. In our current configuration, the human retina is filled with a mix of rod cells, which are sensitive to light and dark, and cone cells, which detect color. To see better in the dark, we'd probably need a higher density of those light-sensitive rod cells. But here's the rub. This might mean a trade-off with the number of cone cells. So, gaining night vision might affect our daytime and color vision. It's a bit like turning down the color saturation on a photo to make the details stand out more. Lastly, we could potentially develop a layer similar to the tapetum lucidum found in many nocturnal animals. This reflective layer in the eye bounces light back through the retina, effectively doubling the chance for light to hit the photoreceptor cells. This could significantly enhance our ability to see in low-light conditions, but it could also have a curious side effect, causing our eyes to shine when exposed to light, the same way a cat's or a dog's eyes might glow in car headlights. So, wider pupils, more rod cells, and a reflective layer in the eyes. These are the key physiological changes that could occur if humans were to develop night vision. And these changes wouldn't be cosmetic. They could dramatically alter our perception of the world around us. From how we perceive colors and shapes to how we navigate our surroundings, night vision could change our daily lives in ways we can hardly imagine. These physiological changes could dramatically alter our perception of the world around us. The ability to see in the dark could have profound societal implications. Let's consider a few. Firstly, imagine a world where nightfall doesn't signal the end of the day's productivity. Humans, no longer hindered by the veil of darkness, could extend their working hours into the night. This could lead to a society that's active around the clock, where businesses thrive in the moonlight and night owls take center stage. The implications for energy consumption could be immense too. With less need for artificial light, we could drastically reduce our energy usage. Cities would no longer need to glow with the hum of street lamps, and buildings would no longer need to be lit up like Christmas trees all year round. This could lead to significant energy savings and a dramatic decrease in light pollution. The night sky, freed from the glare of city lights, could reveal its celestial beauty to all. The safety benefits of night vision shouldn't be overlooked either. Improved visibility in the dark could reduce the risk of accidents, whether it's stumbling in the dark at home or navigating through poorly lit streets. Personal safety during nighttime activities could be greatly enhanced. The societal changes brought about by night vision could be far-reaching and transformative. From a shift in work patterns to energy conservation and improved safety, the impact could be as profound as the shift from night to day. Night vision would not just change society, it would also change our daily lives. Imagine, for instance, a shift toward nocturnal lifestyles. The darkness of night, no longer a hindrance, could become our preferred time for activity. Many might trade the heat and hustle of the day for the cool tranquility of the night, turning society into a 24-hour operation. Leisure and travel habits would also transform. Outdoor nighttime activities like hiking and camping could become more accessible and popular. Picture stargazing on a moonless night or navigating a forest path with no need for a torch or campfire. The world would no longer close its doors at sunset, but instead invite us to explore its nocturnal mysteries. The way we design our homes and buildings might also undergo a significant shift. Without the need for artificial lighting, architecture could focus more on accommodating activities in natural darkness. Imagine homes with larger windows for moonlight or offices designed to make the most of the starlight. Places of work and rest, no longer bound by the cycle of day and night, could take on entirely new forms and functions. In essence, our routines, hobbies, and even our homes could look very different in a world where humans have night vision. But what would be the impact of our night vision on the environment? This is a question that takes us into the realm of ecological considerations and how a shift in our visual abilities could ripple through the natural world. Firstly, let's consider nocturnal wildlife. Many creatures have evolved to be active in the darkness, away from the prying eyes of humans. Owls swoop silently through the night, bats flutter in pursuit of insects, and foxes sneak through the undergrowth. These are all scenes that play out under the cover of darkness, a time traditionally free from human activity. If we were to join these creatures in their nighttime world, the increased human presence could disrupt their natural behaviors and routines. This disturbance could affect their feeding, mating, and survival strategies, potentially leading to changes in population dynamics and even species distributions. Secondly, let's think about predators. Many of them rely on the cover of darkness to hunt. The nighttime is their time, a time when they have the upper hand. But if humans were suddenly able to see as clearly at night as during the day, these predators might find the tables turned. They could be spotted more easily, their stealth and surprise tactics less effective. This could put new evolutionary pressure on these species, potentially leading to changes in their hunting strategies, physical adaptations, or even their times of activity. Furthermore, if our night vision led to a decrease in artificial lighting, it could reduce light pollution, a problem that disrupts the natural rhythms and behaviors of many animals and insects.